Ahoy Captain, welcome to How to Decarbonize Your Ship, a series in which we provide guidance on regulations and decarbonization measures. And in this episode we'll look at a container ship, in particular a feeder, and add shore power to it. As we know, or as most of you know, container ships are obliged to have shore power by 2030 because of FuelEU. And we're gonna have a look and see how much it would cost to refit a container ship with shore power or onshore power supply. And what we're gonna see is that we have 100% CO2 reduction when moored, quote unquote, because, well, we don't know where the electricity comes from, but FuelEU takes into account zero emissions when moored or when using shore power, so that's nice. We're also seeing a CAPEX of roughly 300k, very hard to say of course, but we'll show you more the specifics, the details and where to look out for. I'd say 100k is doable depending on how much time you are willing to spend in man hours. And a bit more than 300k is always doable, but 300 should be a semi-conservative estimate. With the parameters that we use, we see a payback rate of about 6 years, but it's highly dependent on your electricity price, of course the fuel price, but also the CAPEX if you need a transformer on board or switchboard modifications. We're also going to have a look at that. 6 years now, but moving ahead, because we're going to take a close look at FuelEU and also the cost savings involved. It can be a lot less from 2030 onwards. Also there it depends on your vessel particulars, but that's why we have our tools where you can input your own vessel. These tools that we use are of course great, however they are only a model. It's a reference ship, a case study. We need to have your ship specifics and discuss in order to know more. So please keep in mind we take into account a lot of assumptions, even though we have seen a lot of things before. It's also constantly evolving, just like rules and regulations. We are constantly tweaking, updating and improving our tools so that they are better, give more valid results and are easier to use. It is made by humans, so there could be errors in it. Also there we are constantly evolving, but keep in mind that small errors can be made, especially with new stuff. And then finally it's made with publicly available data. So any specifics on the ships we cannot either say or simply don't know, but we take into account a lot of assumptions based on public data. So at least you get something, and the tools can then be used to create that something into something specific for your ship. Enough talking, let's simply dive into the case. And away we go. We are using the Shore Power Quick Scan. This is the membership page, so it has all the premium features. So if you're using the freemium version, you can have a look and see what we can do, but some features might be turned off. As stated, we're going to go for a container ship and we're going to go for a feeder. That's all we need to do. When we press let's go, we get an immediate CAPEX OPEX overview, and that's where I get the 300k from. This is of course only equipment procurement based on the input parameters that we have. We directly go to CAPEX because usually that's what people want to know, but we should go to ship specific first, technical details, then CAPEX, OPEX, tweak a bit where possible, and then we get a business case, tweak a bit more, and then finally we can save our case at the end, and then we have something to present or show off to friends, colleagues, frenemies, everyone. So we're gonna first go to a ship, and as you can see we have the Samskip Innovator as a reference ship, so we took some publicly available data. This of course is extremely important, always the operational profile, especially when making a business case or determining the OPEX. What we do here basically is we have a certain amount of idle moored days, 90, and then we say of those idle moored days, full days, 24 hours, we have 81 shore power days, so hooked on to shore power. And then for that other 9 days we have the generator running still. So 90 days, of course it looks like a lot, but sailing 75% of the time is also a lot. Commonly 25% of the time. Most ships are idle or moored, idling or mooring or anchored about 25% of the time, but we're simply going to change this to a little bit less. You know what? 69 and 62 days shore power. There we go. And we also have the option to change the ship if needed. Then going to ship properties, this is what we have in terms of publicly available data. It's not much, but it's something, and it should be enough in order to get a power demand profile. So in the here we can still have a look, especially main switchboard voltage. 440, it could be 400, 440 or 690, commonly for low voltage shore power systems. That means that the average power demand or rated power is below 1 megavolt amps, MVA, so roughly 1 megawatts. But we're simply going to use this information for now and use MDO as a fuel type. So let's see how the power demand looks like. So we are using a auxiliary engine of 533 kilowatts. It's quite large, I have to say, and only 40% auxiliary engine load on average, resulting in 213 kilowatts of average power. I'll admit, I think it's going to be a lot less, honestly, for these ship types. They usually have quite large engines, sometimes used as emergency sets as well, but commonly they don't need that much power when they are idle moored and containers are being loaded, unloaded, usually done by the port terminal, terminal itself. So we're going to stick with 18%, 96 or roughly 100 kilowatts of power. And then parasitic load of engine, that's a very important parameter. What it basically means is that you need energy to make energy when you run the engine. So you need fuel pumps, fans, all kinds of equipment that are running when you run your engine. Those can be turned off when you don't run your engine. That's what we call parasitic load. Of course, we could have other losses in the electrical system, or you still need a boiler running, or you need heating or whatever. So we simply say there is a parasitic loss. It can also be more, so you can have a negative loss, so that you need more electrical energy to run your systems. But commonly it can be quite a lot, especially for large vessels. I've seen it go up to 40% of parasitic loads, very large fuel pumps, etc. But we're gonna stick to 0 for now, just to keep it easy. And then you see that, okay, the power demand when running on an engine is the same as the power demand when it is electrically moored. Then we have engine characteristics. We don't have an engine name because we don't know, but basically we make assumptions on the engine type and speed, which will lead into, as you can see, a different specific fuel consumption. And you can manually change that as well. So decrease it in order to get a more efficient engine and increase it in order to get a less efficient engine. Let's see, we're now at about 200 something at optimum. Yeah, I'm gonna slightly decrease efficiency, but this should be close to reality for a 4-stroke engine. And then finally we have an overview here in which you have the different operational profiles, the power demands, emissions and costs. Important to have a look at is whether or not the amount of fuel used when idle moored also is close to reality. Of course, sailing, this is given specifically for FuelEU, because we have to take into account all the fuel consumption of the entire year, also for different regulations. But for the OPEX, as you can see here, and also for making calculations on the day rate, etc., we only look at the shore power and regular idle moored profiles, so the conventional profiles. But double check to see if this is indeed your regular fuel consumption when you are moored for 24 hours, I have to say. And otherwise, you have to double check properties. So going forward to equipment, and here we see the main equipment needed for such a vessel. It's a direct drive, that should be correct. The rated voltage is 440, but yeah, you can change to anything you want. But we know that it can be 400, 440 or 690, so I'm just going to go for 690. Rated power 500 kilowatts. As we saw, we probably need a lot less. So if we rate the shore power equipment and switchboard mods also to 500, it's gonna be costly, so we're just gonna stick to it, so that's fine. Most important on your CAPEX OPEX, and we'll see that later, or we can see it right now, is whether or not you need a switchboard and transformer required. So those would be the main things to have a look at. Switchboard required means, do you still have a spare socket or a breaker on your switchboard where you can plug in the incoming shore power? And a transformer, is the incoming power 690 volts or 440? If not, you need a transformer to step down or up the incoming power. That's of course also dependent on the different ports, so we typically leave them as on in order to get the more conservative estimate. Then we have a low voltage system. That means we are below roughly 1 megawatt, and we always do synchronization. And if you want to have a closer look at the equipment isometric view, well, this is simply a drawing of all the equipment, which sort of makes you have a look and see, okay, this is basically what I need. But for the electrical diagrams, we make some more assumptions, etc. This is generalized single line diagram, but you can see, oh yeah, incoming in the main voltage switchboard, and then stepping down to the lower voltage switchboards. This is something to discuss, of course, with your engineers on board as well. We make a lot of assumptions, but it's used to, well, at least give you something. Important to notice that connection panels also impact your cost quite significantly, because if you need 2 connection panels, you need to refit 2 sides of the ship, port side, starboard, cabling, hooking it up to the transformer or not, etc. So it's 1 or 2 connection panels. Well, I'd say if it's obliged and you want to have 2 sides being able to support your incoming shore power, it is very nice, but of course it's quite a big cost. The general arrangements, well, because we don't know much about your ship, that is hardest to say. All we can say is put it as close as possible to your main switchboard, of course, to reduce the amount of cabling and bulkhead penetrations. And finally, some guidance on sockets and plug type from what we can say from the standards, but you probably have to have a look at, well, you always have to have a look at 80005 and NXC normative for these types of container ships, low voltage. So that's the technical side of things. Then going back to the fun part. Now the funnest part is of course the business case, but CAPEX, OPEX. What we do is typically we exclude all design, engineering and refit and class. As you can see, that greatly impacts the pricing. So right now I'm also going to exclude those because it's really hard to say, and also see that when we do it, our business case will be extended to, well, everything above 10 years is for us not a business case, so payback time is infinite. But you can, of course, have a look here at the CAPEX breakdown, and this is a lot, but if we include the design, engineering class, you can see what we take into account for these different activities and aspects. And you can, if you want, manually have a look and go through it to see, okay, this would be 80 for us, oh, this is 20, oh, we don't need this, so this is 0. So you can make your own list of retrofitting, but also equipment and procurement. Based on the technical aspects that we saw, we see here, for example, shore power connection panel, somehow we take into account 37,310. I know why, but it could be that after asking your supplier, it could be, well, this is only 20. He has a spare one lying around. No, 20,000 switchboards and breakers. Well, I can still use my old switchboard, but I still need some components there. Also 20,000. And the transformer, ooh, that one's a bit more expensive. So yeah, that's going to be 110,000. And then you see immediately equipment is updated. And if you have a more generalized, typically complicated vessel, you can also increase refit complexity. That mostly impacts the man hours, and also if your equipment is more expensive, you can add a multiplier to the CAPEX equipment. So these are the overall multipliers, and here you can go down into the nitty and gritty. So we're getting close. It's now even more expensive than originally expected, but okay. You know what? We're going to leave everything in. We're going to make the CAPEX a bit more expensive, and we're going to have a look at the OPEX and see if we can still make a good business case. So here we go. We have fuel, any leasing cost, I'll cover that in the business case, maintenance costs, spares and consumables, EU ETS, and FuelEU costs when conventional or when on shore power. And we can have a look and see if what the effects are of the different prices, and we're going to make a better business case. So we're going to do 0.3. Okay, so in this case we have about fuel price parity, but we have most of the savings in maintenance, EU ETS, and a little bit in FuelEU as well. But we can see that when we add reporting years, that FuelEU will be a lot larger impact, and even though this looks very small difference, that difference will definitely start counting at the long run. Yeah. So okay, EUTS a bit more, so we're gonna have a more positive business case. Oh yeah, engine maintenance. Typically this is quite a lot for larger engines, so we're gonna reduce that a bit. So let's see, we still have a total reduction in order to get a business case. 9 years, not great, pretty terrible. So going to business case, let's see, how can we improve our business case? Well, the first thing of course would be to have a look at the number of days moored, but well, that's usually pretty much fixed. It's harder to change that, so we're gonna leave that roughly at 70. Fuel prices, we also cannot really influence that, so we're gonna also leave it at what it is. Electricity price, that might be something we can influence, or we can have a look at leasing. Yeah, this is also not great. We still have quite a high exposure, less than originally expected. Well, and we have a year later payback rate, so maybe if we have good leasing conditions, this could be an option in order to reduce your risk and exposure. So let's customize the business case. Inflation and net present value, that's for the CFO, so I'm gonna leave it. We can also see if we can expand. Yeah, so the further we go down into the future, the better it will look for our business case, because like I said, that FuelEU difference will be more pronounced. But yeah, 2050 we already need it in 2030, so just gonna leave it at 2025. So it's actually going to be pretty hard to make this a better business case, and seeing that we already have some savings, I'd suggest in this case going back to the CAPEX and simply seeing how we can reduce cost. Well, I can do it easily by clicking on these values and then, hey, the business case is better, but that would mean going really into detail with engineers and seeing where you can reduce costs. One final note before we move on to the feasibility report itself. Here we have the FuelEU Maritime costs, and as you can see, with FuelEU we save about 25,000 euros per year starting in 2025. But if we do show more, then you can see indeed our savings are 30,000 and increasing slightly towards the end. So all in all, going forward from 2025 to 2050, we have a little over 1 million savings, and we have 300,000 savings in the first 10 years. So that's already quite a lot, I have to say. And that's well, I have to see if that's, yeah, and I had to see if that was correct or is correct. There could still be a small error, but this of course is quite a lot of money, and it looks like as if not everything is discounted into the operational profile for idle moored. So we also discount some of the savings into the sailing profile. And that's always tricky making a business case. We make assumptions, you might make them differently, and we'll double check to make sure that it's rightly reflected into the cash flow. Suffice it to say, only looking at a FuelEU, one, it's obliged to have shore power. Second, you still have some savings that would, of course, over the course of 10 years, make it more of a profitable business case. But how you're going to discount the total, that's that's harder to say. Once you've made a business case, finally, the subsidies. This is a very limited overview of subsidies, but we can add, of course, maybe some subsidies. Perhaps we can have a small amount of money, and as you can see in this case, this would definitely be quite a benefit. Right now, however, it's getting harder and harder to get a subsidy for shore power because it's becoming mandatory, so be quick. Final note, you can save your case, so we can do feeder, and we can save our report. Here we go. And if you press get report, you get something like this. This is of course the example for a different vessel, but here you see the main details that we have discussed, and it will be inputted with your vessel, your operational profile, etc., etc. As you can see, a lot of information is included here. Everything that we have discussed should be in there, and you can always contact the help desk at any time to get more clarifications on any questions that you might have. And if you want to make your own business case and make use of the premium features, you can always download the Excel, and of course that Excel is freely accessible to all members. And that's it for our e-feeder. So make sure to sign up and become a member. Choose any membership in order to get access to these kinds of tools and make your life easier, faster business cases, more beautiful business cases, anything you need to get more grip on sustainalizing your ship. Thanks for watching this video and have a great day.